Welcome to Science Access. In today's class, I'll be starting the set series with the introduction to set. And I'll be following this outline. I'll actually introduce you to set, talk about the finite and the infinite set, talk about the subset and the superset, equality of set, as well as equivalent set, universal set, the unit set, or which is also called the Singleton set, as well as the empty set. Then finally, we'll talk about the cardinality of set. In the part 2 of this introduction, I may define some other terms such as the power set and some others. If you know you are new to this channel, please kindly press the subscribe button and put on the notification so that you get notified whenever I post a new video. What is set? Set can be defined as a group or a collection of well-defined objects or numbers. In real life sense, you can even refer to a set of cars in the garage, set of spoon, or even group of people. For example, set of students in a particular class. So these are practical sense which you can use the term set. For example, let's learn how to describe a set. A set is usually represented with capital alphabet. So let's assume that a set A, which is a capital letter A, comprised of even numbers between 10 and 20. So set A. A set is usually covered or is enclosed with a curly bracket. So a set A comprised of what? Even numbers between 10 and 20. How do I describe this set? It simply means if I want to describe a set A which comprises of even numbers between 10 and 20, I'll have to list out the elements of the set. What do you understand by the term element of set? These are actually the items or the objects within the set. They are regarded as a member of the set. For example, even numbers, we have even numbers between 10 and 20. So the even numbers between 10 and 20 are actually the members or the elements of this set. So let's describe this set. Set A. Set A. Put your curly bracket. What are the even numbers between 10 and 20? Before I talk about the even number between 10 and 20, what are even numbers? These are numbers that are divisible by 2 and you have no remainder. So between 10 and 20, you can divide 12 by 2. There is no remainder. 14, 16, 18. So these are the even numbers between 10 and 20. You can just try to divide them by 2. You will not get any remainder. So they are the even number between 10 and 20. So these are the elements or the members of this set. Remember, elements are separated from each other by a comma. You can see the comma separating one element from the other. And if elements are actually alphabets, they are represented with small letters. If they are alphabets, they are represented with small letters. So let me just give you another example. Let's assume that we have a set B comprised of vowel sound. We have a set B. Put your inverted or the coiling bracket. What are the vowel sound? A, E, I, O, and U. So the set, which is B, is represented with capital letter B. Now the elements, which are A, E, I, O, U, they are represented with small letters because elements of the set, they are represented with small letters and they are separated by what? A comma. So I have successfully described a set A, which comprises of even number between 10 and 20. I have also successfully described a set B, which comprises of what? The vowel sound by listing out their elements. So this is how we describe a set. So how do you describe a set? It simply means you write out the elements or the members of this set. Let's talk about the term finite and infinite set. So what is a finite set? A finite set is actually a set in which each member or each element can be counted. For example, I can say the set of cars in the garage, you can definitely count them. Or which other thing? Odd numbers between 1 and 10, you can do that. Or numbers greater than 1 but less than 10. So if I say write out a set of numbers greater than 1 but less than 10, the number must be integer, that's whole numbers. So in this case, set A, numbers greater than 1 will have 2, 3, 4, 5, 6, 7, 8, and 9. Now, note that the number here, whole numbers, they are actually greater than 1 and less than 10. So, this is a finite set because each member or each element can be counted. But what about if I decide to just say number greater than 10? A set B comprised of number greater than 10. So, we now have set B, number greater than 10, right? So we now have 11, 12, 13, 14, and it's continuous. It's actually endless or indefinite. So you present it with this symbol, then this simply means that it continues endlessly. So this is actually an infinite what? Set. Infinite set. Why this set that each member can be counted means what? It's a what? A finite what? Set. So please take note of that. Let's talk about the next item here, which is subset and superset. Let's use two sets to illustrate subset and superset. Set A comprises of members 1, 2, 3, 4. Set B comprises of members or elements 1, 2, 3, and 4. So because all the elements in set B is actually present, all the elements in set A is actually present in set B, we can regard set A as a subset of set B. So we can regard set A as a subset. This is symbol of set B. But in this case, all the elements in B is also present in A. So we can also regard set B as a subset of set A. Remember, if set A is a subset of set B, that means set B is a superset of set A. So we can put set B is a superset B is a superset of what? Set A. But let's change the question a little. Let's add an element to set B. Add 5 to it. And we'll now have a situation whereby set A, all the elements in set A is present in set B, but there is an element in B that is not present in A. This one, set A, is now regarded as a proper subset. So know the difference between just a subset and a proper subset. In some cases, subset can be equal just the way you see it here. Set A is actually equal to set B. So, but in a proper subset, set B contains an additional, at least one additional object or number that is not present in A. So in this case, we can regard A as a proper subset of set B. So in this case, we can put it this way. Set A is a proper subset of set B. Note the difference in symbol between a proper subset and just subset of set B. While B can be regarded as a superset of set A. So B is a superset of set A or a proper superset of set A because it contains an additional element or an additional member not present in A. Please take note of the symbols for superset. B is a superset of set A, while A is a subset. This is a subset of set B. all right, proper subset for set B. Let's talk about equality of set and equivalent set. So let's talk about equality of set and equivalent set. Now, let's illustrate using set A and set B. Set A has elements 2, 3, and 5. While set B has members 5, 3, and 2. Now, if you notice, you realize that the members of set A, 2, 2, 3, 3, and 5, 5, irrespective of the order in which they are arranged, is the same thing as the members of what? Set B. So this set is set A is said to be what? Equal to set what? B. So set A is equal to set what? B. But if I decide to change to or to add just one element to this set B, we can now say set A is not what? Equal to set what? B. So please note that set A is equal to set B if the element in A is actually the same element in what? B, provided irrespective of the order in which they are arranged. All right. Now let's talk about equivalent set. Let's talk about equivalent set. If I decide to change this to 7, you realize that the members of set A is not the same as the member of set B because we have 7 here, we don't have 7 here. But the number of elements or members in set A is the same thing as the number of members in set B. So this set A is said to be what? Equivalent, not equal. So this is not equality of set. This is equivalent what? Set. They possess the same members of elements. We have 3 elements here, element 1, element 2, and element 3. We have element 1, 2, and 3. So we have 3 elements here, 3 elements here. So both sets are said to be what? Equivalent. So they are equivalent sets, not equal sets. All right. So please note the difference between equivalent set and equal set. Let's discuss universal set, unit set, as well as empty set. So let's talk about the universal set. A universal set for any given problem or challenge is a set that contains all the members which is used for that problem or challenge. Now, the symbol for universal set can be represented by U, or some cases you see this symbol being used. I have a universal set in this way. Let's just assume as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, there can be other subsets under a universal set. You can just have 2, 4, and 9. So you can have various or more than one subset under a universal set. And any challenge, any question, problem that need to be solved, the number is within this universal set. So that's the reason why it's called a universal set, because any challenge that arises from any questions regarding this universal set, it contains elements or members that can be used to solve, that can be used for that particular challenge. All right, so we can eventually put this A is a subset of this universal set. So in this case, the universal set is actually acting as a superset. Note that when dealing with Venn diagram, you see Venn diagram, you draw your cycle as for the set and all that. But universal set in Venn diagram is usually represented with rectangle. Rectangle. So know the difference. When we are in the part 2 of this video of set, I will introduce you to Venn diagram. All right. Now let's talk about the unit set, or what we call the Singleton. A unit set is simple. It's a set that contains only one member or one element. For example, let's assume that a set A has only the set A has only one element, what will you call this set? It's a singleton. Singleton or a unit set. You can have a set A having just an element E. What will you call it? A singleton. So, but what about a set that have no element at all? Let's assume that we have a set B with number of individuals above 500 years old. Is there any number? Is there any person or individual with above 500 years old? No. So this set B is said to be what? An empty set represented with the simple symbol, or see, this is actually empty. So you have two symbols that can be used to represent an empty set. Another name for an empty set is called a null set. Null set. Set. Why the last one that we are going to discuss is the cardinality of a set. The cardinality of a set. So when we are talking about the cardinality of a set, it simply is regarded as, or we are talking about the numbers of elements, the numbers of members that a particular set actually have. For example, let's assume that we have a set A with A, B, C, D, E. What's the number of elements in this set? 1, 2, 3, 4, 5. So the cardinality of this set is actually what? 5. While set B, we have 1, 2, 3. The cardinality of this set is actually what? 3. Another set, for example, we have a set C, which is an empty set. Which is what? An empty set. So what will be the cardinality of this set is what? 0. So that's a very simple explanation for cardinality of what is set. It refers to the number or the number of members a particular set actually possess. In the part 2 of this video, we'll be talking about other terms such as power set and others. They may even introduce to Venn diagram as well as union and some little calculations. Thank you for watching. Please subscribe to support this channel. Thank you.